Okay, welcome back. Thanks for joining me again. My second session of the day. It's going to be a little bit more cutting edge and a little bit more live than the last one I did on recognition. Here we're going to be looking at building chatbots with Amazon Lex, something that I've learned a lot about over the course of the last couple of weeks while trying to build a good demo for this session, which I'll show you a little bit later on. Not entirely finished, but finished enough for me to show you quite a few of the core concepts that we're going to be talking about here. So I did introduce myself before, but if you joined us just now or you're joining us on the stream, hi Twitch. My name's Ian Massingham, I'm a technology evangelist with AWS. I've been with Amazon quite a long time actually, about we're coming up to 4 years, which is longer than 72% of the people in the company, so quite a while. So chatbots with Amazon Lex. Lex is a service that we launched last year. I mentioned it briefly in my prior session. It's one of these abstracted services that makes use of a deep learning neural network, but it doesn't require developers to know anything about deep learning neural networks. And in this case, the neural net is put to use for quite a few different things. So I'm going to talk about that in the course of the session. It's put to use bidirectionally, so it's used to understand input to the chatbot, but it's also used for another purpose, which in my view is more interesting, okay, and a little bit more nuanced. Okay, so we'll get to that in a second. Here's what we're going to cover before I get to the console, and the idea here is to spend most of this session in the console showing you how to build stuff. So we're going to quickly get through like 8 slides, and then I'm just going to go live in the console and show you how to get started and build these interfaces in the console. So why did we build this? Well, there's a natural evolution taking place in the interfaces to machines that we use to build information systems, okay? Who remembers this? Bob, hi. Bob's a very active member of the AWS community here in London, so I'm not picking on him unnecessarily. I knew that he would answer the question in that way. So. You had to? We didn't call it Hello World. No, you needed a filing cabinet for that, right? Full of these punch cards. So yeah. So then you got onto the GUI, okay, which is, you know, probably what most people of my generation, the 30, 40-somethings, 40-somethings in my case, grew up with. So when we first sort of booted Windows 3.1 for the first time and moved away from MS-DOS, it was like, wow. This is amazing, okay? And that same kind of experience has been replicated for me much more recently with the Amazon Echo. So there's something really magical about speaking to a machine or information system or application and having responses to your question given to you in real time in a way which is almost like, you know, talking to the Starship Enterprise. And this, I think, for me, there's one really good example of how impactful this is. I was at an AWS user group in Dublin, and in the AWS user group in Dublin, which, by the way, you should go to an AWS user group, no matter where you are in the world, go to them. They're a really valuable resource for customers to learn from peers, unfiltered by AWS or anybody else, just genuine community knowledge sharing. They're a fantastic resource. The one in Dublin is really, really good, and they have a subgroup, like a side group, that focuses specifically on Alexa development, Alexa Devs Dublin, which is actually very popular in its own right. When they were starting this up, they wanted somebody to come in and illustrate how revolutionary the voice-based interface was. They found a person that was visually impaired, somebody that was almost blind, that had previously not been able to interface with the kind of applications and systems that we all take for granted. Imagine never being able to use Google. And literally, it was that transformational. He got the voice device. Within a few hours, it had completely transformed the information that he had at his fingertips and the services that he could use. Okay, so this is a big deal for accessibility. It's a big deal for making information systems and services available to groups that have traditionally been excluded. And it's also a big deal from a commercial perspective because you can access markets that you might not have previously been able to access. Okay, my kids, for example, they can control Spotify. In fact, the most popular Alexa utterance in my house is the following phrase: Alexa, play Black Magic by Little Mix on Spotify. It ranks way above any other utterance because my 5- and 7-year-old say it 50 times a day at the weekends, you know? So, yeah, accessibility is really, really important here. Of course, there's some challenges in building systems like that, okay? So these are some of the challenges that developers face. With Alexa and the Amazon Echo, we're tackling these challenges for a specific device, okay? In order to deploy your skill within the Alexa Skills Kit, customers need to have an Echo or another device which is hooked up to the Alexa voice service. Now, you can connect your own device to that, but you do have a dependency then on Alexa skills, on the programming model, and on fitting within that framework. Okay, what we're trying to solve for with Amazon Lex is disconnecting that, removing that constraint, removing that assumption that you're going to be building your application for users that are interfacing with the Alexa voice service. Lex itself is a standalone Amazon Web Services API endpoint, or is represented by a standalone Amazon Web Services API endpoint. And using the service, you can deploy a fully featured chat service behind that endpoint, and you can interface it with a variety of different channels. We call them channels. So this is things like Facebook, Slack. You can write your own clients, which use either text-based interfaces or use voice-based interfaces. So you can build a special purpose chatbot with a speech-based interface that allows your customers to quite literally talk to products that you're building. So you could build a washing machine, a home security system, a car, a special purpose kiosk that gives tourist information, a safety unit that goes on public transport that individuals talk to. These could all be physical devices that use the human voice for communication, but are actually backed by special purpose chatbots running in Amazon Lex. Okay, so you have the capability to decouple the physical device, use your own special purpose physical device, or have this open connectivity into a variety of different channels that are the locations that your users are already present in. Okay, so they're already on Facebook, they've already got the Facebook Messenger, they're already on Slack, they've already got Slack clients. You can deliver your services into these pre-existing ecosystems using tools and interfaces that your customers are already using. It's really, really important from that perspective, I think. So, like I said, there's two sides of the service. Speech recognition, okay, and then natural language understanding. So these are important distinctions. The same phraseology that's used in the Alexa skills kit actually with the Echo. So speech recognition is what words did I say and in what sequence. Okay, so I want to book a hotel. I just said, I want to book a hotel, right? But what do they actually mean? Well, in that case, I meant, I want to book a hotel, which is the NLU. But I might have said, I'd like to book a hotel, please. It's the same intent, right? I mean the same thing. Or, I want to book a hotel in London next week from Wednesday to Friday. My budget is £200 maximum. A very complicated phrase that needs to resolve down to the same intent. And this is what NLU is. NLU is unpacking the tens of thousands, hundreds of thousands, or millions of different ways in which human beings can say the same thing. Okay, and that's where the deep learning neural network comes into play. It comes into play in unpacking your intent, and also, of course, this is every bit as important, extracting the pertinent data, which we call slots in our programming model, that relate to the intent. So in London, next Wednesday, next Friday, £200. Location, start date, end date, budget. Okay, and I need to be able to pick those out of the model. Even if I say, I want to book a hotel in London, departing next Friday, but arriving on Wednesday, my maximum budget is £200. Yeah, same thing, same slots, completely different sentence structure. Imagine trying to do that with a case statement or a switch statement in a traditional programming model, like a gate-based model. It's just completely impossible to do that. And that's where the pre-trained neural network that we operate comes into play. It comes into play in unpacking the meaning from those sentences and pulling out the important components. And as I said before, you can deploy in Facebook Messenger, in Twilio, with one click. You can integrate with Slack. You can deploy to mobile. In the case of deploy to mobile, you can use our mobile SDKs on the Android and iOS platform, and you can use an adjacent complementary service that we have called Amazon Cognito for identity and credentials management on those platforms. Okay, this allows you to issue scope-limited and time-limited AWS API credentials to mobile apps, and to have those mobile apps work in a secure and trusted way with our AWS API endpoints. So for that particular model, we have another adjacent service called AWS Mobile Hub that will build you a skeleton application for the Android or iOS platform, including the components of our SDK that are required for you to deliver whatever functionality you want. So basically, Mobile Hub will build you a source code package that includes the right features from AWS to use services like Lex in mobile application development. I'm not going to say much more about that here, but it is a good way to get started if you are a mobile developer and you want to put a speech button in your app where your users can use a touch-based interface for your app, but they can also just press a button and tell your application what they want, which might help you reach excluded audiences that don't have good written English skills, for example. Okay, so you can do that very simply in the app as well. Okay, so let's get out of these slides. I'm going to sit now. I hope that's okay for the camera at the back and that you can still see me okay on the stream. I need to concentrate on this next section. So I wanted to do something here, which is to show you the interface and then talk a little bit about the bot creation process, okay? So let me switch to this screen, and I'm going to make this full screen. So you'll see I've already got one bot that's been created here within my console. I'm just in the Lex console here in the North Virginia region, which is the only region currently that supports this service. I'm in that console and I have one bot that I've already created. I'm going to come back to that later and describe the functionality of that bot and show you how it's accessible and then show you how it works by showing you a little bit of code that's been implemented at the back end. But before we do that, let's look at creating something from scratch, okay? And what we've done here with Amazon Lex, I'm just going to hide this toolbar to make a little bit more space. What we've done here with Amazon Lex is to provide several different startup options for developers. So you can take one of our samples, okay, and you can quickly deploy it into your account to see how it works, or you can create a custom bot from scratch. If I go to create a custom bot from scratch, I'm asked to enter descriptive information about the bot, and it will then take me through creating, let's do this, okay, so London Loft demo, okay, choose my output voice. I'm actually going to use text here, so it's a text-based application. I want a 3-minute session timeout. Then I've got some IAM stuff, and I've also got some legal terms here that relate to making these services available to children, because there's a specific regulatory framework for that. So I'm going to say no for that, okay, to simplify the process. And then I'm going to create my bot, create an alias. My bot's called, oh no, let's not go straight to that. Let's go to alpha, okay? And let's use latest for alpha, okay? And then in general, oh, that's it. I can save that, so. Okay, so in these other, so the next thing I need to do is to create an intent. So I've created the basic settings for my bot. I need to create an intent. So what is it that I want my bot to allow users to do? Okay, so if I hit create intent, I can create a custom, or I can use an existing. There's some custom intents that are already created in the system. I'm going to create a new one. And let's go for something nice and simple. So let's go for today's weather, okay? So I need sample utterances. These are essentially pieces of training data that will prime the understanding capability of the neural network so that it can detect when a user is invoking the intent that I'm creating. So here I would have, like, what's the weather today? That'd be one example. Can you tell me the weather? What's it like outside? Is it raining? Is it sunny? Oh, sunny. So I'm creating sample phrases which are used to initiate the intent. Okay, those will prime the model, and that will help my bot detect what it's being asked to do. I don't need to create an exhaustive list, but I can use this for tuning. So if I have a missed intent, which I'll show you later in metrics. In other words, somebody's trying to invoke my bot via one of the channels, but they're saying something that we can't figure out what that is. Then we can use this to add additional kind of capture phrases that will be used to route users to this intent in the future as we try and cover all available permutations of the invocation phrases that are available. Okay, and I'm just going to have location. And there are built-ins here, okay? So built-ins for European cities. I can have a prompt, which city are you interested in, question mark, okay. And I can save that intent. I'm going to return the parameters to the client. This is as much as I need to do in order to build my bot. So I can build it, okay? And what's happening now is this is getting pushed out into our infrastructure, the intent priming. I can't have question marks, sorry, that's my mistake. So you don't need punctuation in these. Let's remove all those. So the sample utterances are being primed now into the system, and the bot is being deployed here for testing. Okay, so in a minute this will complete, and I'll then be able to show you the next step. Now you notice that I didn't select these advanced features like Lambda initialization and validation, a confirmation prompt, and at the very end all I'm going to do is return parameters to the client. So this is about as simple as it's possible to build. Okay, and then I'm presented with this testing panel over on the right-hand side, and I can chat to my bot. So what's the weather? Okay, so it's getting ready to fulfill. Now, I haven't got any specific pieces of data that I am trying to capture here, okay? But if I do enter specific slots that I want to capture, so let's have a slot called location. Save that intent. And that work? Seem to get deployed. Let's create a slot type. Okay, this should now work. Do a quick rebuild. So there what I'm doing is adding the specific data that I need to capture in order to fulfill the intent that I'm creating here. Just rebuild that and redeploy it. They say a watched progress meter never finishes, I don't know if you've heard that. So I build and redeploy. Okay, there we are. So there we're now looking for that missing piece of information that I've asked for, and I can say London there. Okay, so that intent is now ready for fulfillment, and I've specified a piece of data which is one of my slots, and I have captured that. So that is the most simple Lex bot that you can build. Okay, it's ready to dispatch that event to a fulfillment function, and you can use this for building your language model and training or creating the front end part of your conversational interface without having to be concerned about fulfillment or any validation of the values that you're entering for your particular use case. Okay, so that's all you need to do in getting started to build the interface. It's far too simplistic an example to be representative. So let's move on and take a look at something which has got a little bit more to it. Just quit out of this, and I'll show you another use case example. So you might recall there were a couple of available examples there in the console that related to, one related to booking flowers, one related to booking travel, so traveling to a city. And it's this travel booking one that I just want to focus in on for a few minutes and talk about. So this is one of the sample bots that can be deployed via the console, and I will deploy it in a second, okay, and show you how that works. And in that sample, we've got much more sophisticated back-end logic, okay? And that back-end logic is expressed using AWS Lambda Functions. And you might have seen this. Initiate a dialog fulfillment function, or initiate dialog code hook, I think is the phraseology that's used in the console. What that means is when our intent is detected, or a conversation is detected that has that intent, we fire up a specific Lambda function, okay? And we pass the Lambda function information about the current conversational state, okay? And I'll show you some documentation about that in a second. Because we know the format of the data object that we receive that reflects the current conversational state, we can write an automated processor that responds to it. We can use this automated processor in the form of a Lambda function to interactively control the conversation in a way which is dynamic. Okay, so we can ask for specific slots that are missing with specific dialogue that we create. We can perform validation operations on specific slots, maybe selecting cities only from a valid list of cities, or validating that dates are in the future, or performing pricing calculations to enable us to return back information to the session which is dynamic in nature, even which comes from information sources that are external to the bot itself. So the Lambda function is an executable piece of code, and that executable piece of code is capable of responding to the chat session which is being run with the user. This is how we build the richer experiences. So we're using the same things. We're using intents, we're using utterances, we're using slots, and we're using fulfillment. But because we have the capability to develop very sophisticated logic, to call out to other systems, and to dynamically generate responses that go back in the session, we can build very sophisticated logic flows as part of this process, as part of this platform. So we're able to do things, as I said, like validate sessions and to provide a really rich and interactive experience for customers that are using that service. So the next thing I'm going to do is show you deployment of one of those sample applications. I'm going to deploy the Lambda function, the template function. We're going to do a little bit of testing with something that's a little bit more sophisticated. So back in the console, let's go back to our bots, and we're going to create a new one here. Okay, and we're going to create an instance of this book trip. Okay, book trip London Loft. Same process applies. But here we are deploying a pre-created template, so a pre-existing schema, essentially, a pre-existing object that defines a set of intents and a set of slot types. Okay, so we're going to deploy that in the background. While we do that, we're going to jump into another AWS service, which is AWS Lambda. And over here, we're going to deploy a new function, okay? So we're going to deploy a new backend function. If you're not familiar with Lambda, which is our function execution service, there are a set of templates available within Lambda when you're creating new Lambda functions. There's actually a lot of them for web applications, for APIs, for Alexa skills, okay? But there are also templates that correspond to these demo Lex functions that I was talking about before. So if we deploy Lex book trip Python into our account, the code for which is here, which I'll return to in a second, okay? All we need to do is specify a role that we're going to run this function under, which is our Lambda basic execution role. What am I missing? The name, yeah, good spot. Okay, that's deployed. That's fast. And our template function is also deployed, so we can build that. And you'll see in a second that there is substantially more functionality here, but the same configuration details are still present in the console. So I still have my sample utterances that you can see here. In a second, I'll scroll down and show you more of the slots as well. While that builds, let's just take a look at the code that I deployed in Lambda. So there's quite a long Lambda function here, which has an intent router in it. Okay, so the first thing that we're going to do when we run our function, we're going to receive event context, which you can see here is being captured in this event and context variable here. And we're going to dispatch the event metadata, which is the JSON structure that defines the current attributes of the conversation that's taking place via the conversational interface. We're going to dispatch that into this intent router. Okay, so you can see we've got our intent request here. And there we have routing logic, which reflects the name of the intents that are present within the Lex console. So you'll see these two intents up here match up with the logic in the Lambda function. So you can see we're going to check our intent name. If our intent is book hotel or book car, we're going to dispatch that off to a handler. And those handlers are coded here. So these are quite long validation functions. So to book our car, we're going to pull slots out of the intent, and we're going to validate whether those slots are valid slots or not. This is where we're going to do things like look at whether we're in a supported city. We're going to look at whether our date is actually in the future. We're going to look at whether our return date is after our pickup date. We're going to validate the age of our driver. We're going to validate the type of car that the user has requested. So we can build very sophisticated validation logic in the handling function that we create here. And that gives us the capability to do things like this. So book a car. Okay, in which city do you want to rent? I want to rent in London. What day do you want to start your rental? Yesterday. Tomorrow. The driver is 18. Now you'll see that this does not work, okay? So at the moment we haven't connected our code hooks, but the dialogue is there, okay? So we're capable of collecting the information, and the dialogue is what you can see in these prompts here. If we connect to our... Oh, I've got to reload the console, yeah. So I'll quickly reload the console. Okay, so I'm now going to intercept the dialogue process, and I'm going to feed that dialogue process through that Lambda function that I've connected to this specific function. So I need to build and republish that with the dialogue function hooked in behind the interface. Just take a second. Hope somebody can remember the answers that I gave to those questions, because I need them for testing. Okay, so I'm going to test you on that in a second. Now, one of the good things about this system is once you've frozen the front end and you understand your sample utterances, your slots, and your default prompts, you can then you then don't have to redeploy the bot to experiment with the validation logic in the Lambda function. Once you're pointing at the Lambda function, it's simply the Lambda function that needs to be replaced in order for you to modify the logic that's embedded within the interface. And that is a much quicker process, actually, than that bot rebuild that you've seen there. As you may know, you can push and overwrite a Lambda function in just a couple of seconds. So let's do that again. Book a car. Where do I want to book? I want to book in London. We do not support London as a valid destination. Please specify a valid destination. So let's go for New York instead. When do I want to book? I want to start yesterday. Reservations have to be scheduled at least 1 day in advance. So I want to start tomorrow. And I want to return it on Sunday. How old is the driver? The driver is 18. What type of car do I want? I want mid-size. So you can see how I've introduced validation logic there. Okay, thanks, I've placed your reservation. So I've been able to introduce validation logic by using the dialog handler in the Lambda function to validate the slots and return responses when the slots are invalid. Okay, so that's how we build the richness in the interface. For logging purposes, obviously the intent's not fulfilled in this particular case, but for logging purposes, the same logging that we use for AWS Lambda is used for obviously observing the function and establishing how the function is behaving and what operations it's performing. So if I jump into my CloudWatch logs console here, you'll see I should have a booktrip Python log stream, which is here, which has got information in about the transaction. This is an older one. Okay, let's go back. This one. Yeah, this one. So that's just been generated now. Yeah, it's been generated about a minute ago. You can see this is the debugging data that comes out of the function. Now, something that you should notice here is there are multiple invocations of this Lambda function. So each time I cycle through that process of interacting with the backend via that Lambda function, my Lambda function is reinvoked. Okay, and I'm receiving information at that point about the state of the dialog. Okay, and that allows me to move through the validation process, iteratively prompting for completion of the missing slots, iteratively performing the validation of the data that's in those slots that have just been entered. And then once I have my data model and everything is valid, I can then execute whatever logic is required to fulfill the function. In this case, I'm just logging, as you can see here, logging the data that's been recorded in the validated slots. And normally I would dispatch that off probably to an external system to actually perform the booking operation. All make sense? Okay, good. So that's getting started with one of those samples. And getting started with one of those samples is what I did to build this next demo. This is not quite finished, but it's getting towards being finished. This is another bot called Session Feedback Bot, which is intended to be deployed into the Facebook channel. And I'm going to use this in my team, actually, to allow my team members to solicit feedback for talks and events via Facebook chat. So we'll go to events like this, post a URL for a Facebook page at the end of the session, and allow customers that have attended the session to give us ratings and also leave a long-form feedback about what they've seen. Okay, so we're going to try and open up some more interactive channels for discussion with customers. You'll see here I've got several intents. The reason I've got several intents is I want to have several different pieces of functionality, but I also have a specific intent for help me, because on the Facebook platform, in order to pass approvals for Facebook chat apps, you have to provide a self-starter guide that enables users to understand what your bot does without having to visit a website or page outside of Facebook. So we've got a help intent, which is here. I've got a code initialization and validation hook that I'm using. You might notice that my CI/CD for the function that I'm using is being managed by another AWS service called AWS CodeStar, which allows me to establish a build pipeline for my Lambda function, commit changes via Git, and have those changes continuously deployed into production. So that's how I'm managing my pipeline. And then I have at the moment just one intent which provides functionality, which is rate session. So, and you'll notice that I've got some single word utterances here. It's because I identified an issue that single words were being interpreted as requests for help. So I scoped down my utterances to respond specifically to words like rate and score with the rate session intent. Okay, so this was detected by looking at testing data and establishing that some events were being, some intents were being miscategorized. I'm able to provide higher resolution and make sure my intent is properly picked up. Then I have some slots. ID, session date, session location, and session score. I have a confirmation prompt, and I have a Lambda function for fulfillment. Okay? Yeah?
Is it possible to answer several slots at once?
Yes, yeah. I haven't actually tested that, but on the book car, you can definitely do it. For this one, if I wanted to respond to several slots at once, I would need to create sample utterances that had examples of that. So if I created a sample utterance which was, I'd like to rate a session from today, and then I insert the today or session date slot into the utterance. Okay, so I'd like to rate a session from today. That would enable me to pick out that slot from a complete utterance that included it, but I'd need to enrich my sample utterances a little bit more than I have done in order to implement that, but it will work, yes. Yeah. And then the other thing that I've got configured here is a channel. And the channel that I have configured is a Facebook association. Now you can't see the details of your channel and change them after you've created it. That's for security reasons, because there are secrets there. So you have a one-time configuration operation that you go through where you enter a verify token, which is a shared token that you also enter into your Facebook app. That's used for verifying transactions to and from the webhooks bidirectionally. A page access token, which is a token generated by Facebook for validation, like a secret key, and an access key in AWS terms, and then the app secret key, which is like our secret key for request signing. Okay, so you enter those things. Facebook gives you a callback URL. You enter that, and we give you a callback URL that you enter on the other side, and then the applications can communicate with each other, or the two sides of the application can communicate with each other using webhooks. Okay, sorry, the question for the benefit of the stream that I answered, sorry, it was about picking up slots directly from an utterance without having to enter into a dialogue. So whether or not it was possible to create a bot which can use the sort of logic that I just described. I'd like to rate the session ABC1 from today, 4 out of 5, for example, pick up those slots in a single utterance without entering into a dialogue. In this case, I've not built that, but I could quite easily build it using the technique that I described, so enriching the sample utterances with the slot data. Okay. And then, of course, I have source code on the back end, which enables me to implement the logic, which I'll just quickly show you. It's here. Same kind of structure. So I'm receiving the event in the Lambda handler. I have my dispatch intent, which is my intent router. Here you can see that I've got my 3 intents. So my help me intent is here. And it's very simple. This one, it just immediately returns fulfilled with the content. Hi there, right now I can rate sessions or events where you've seen me speak. To rate a session, say, I want to rate a session. I need to know, and then it tells you the data that it needs to know. And that'll just be immediately echoed back in the session. Okay. The other intents that I have, the feedback intent is not implemented yet, but the rate session intent is implemented and will do a similar thing to that which you saw with the trip booking. It will collect the data that's required, and at the moment it will echo that data into the log, so I can see that the data's being collected correctly. And in the future, what I intend to do here is send the generated JSON objects into Elasticsearch, and then build a Kibana dashboard that enables me to visualize the rating distribution for different sessions. That will be the data model that I use at the end. And I actually insert the user ID that you can see here, which I unpack from the event, into the object as well. The user ID is unique and it's associated with your Facebook ID. So each individual user that communicates with this chatbot from Facebook will have an immutable identifier that is always associated with their particular Facebook identity. And I can use that with some logic later on to eliminate duplicate votes, for example, to enable me to ensure that individual users can only vote once for each session. So I'll implement that later on as well. In terms of testing, well, I can test this in the interface here, obviously. Am I on the wrong bot? No, I'm on the right bot. So, I want to rate our session. Which session did you want to rate? Intro to Lex. And you can see the debugging output down here by the bottom. This is a new feature, so we actually echo the session state in the lower part of the panel here that you can see as well to help with debug. What date was the session? It was yesterday. So this is quite a neat feature with dates, that it will allow me to use natural language and resolve them down to ISO format dates within the system for me. So I could say last Thursday and it would do the same thing, or next Friday and it would kick a validation error saying that you can't rate a session in the future, obviously. It took place in London. How would you rate the session? Well, obviously I'd rate it at 5. I would, wouldn't I? Yeah, so are you sure you want to submit? Yes, I want to submit. And that's it, I've rated the session. My help intent also works. Yeah, so right there, hi there. Right now I can rate sessions or events, and I can also give feedback. Ooh, I can't take session feedback yet. You notice I spelled feedback wrong, but it still corrected that in the neural net and was able to resolve the intent, even though I had a typo in my intent. It's pretty smart. Okay. And then on the Facebook side of things, well, the main thing about the Facebook side of stuff is there's no difference. Okay, so it works in exactly the same way. It's just the interaction channel that is different. Okay, you need a Facebook page, obviously, to deploy that, but I can do the same thing. I can ask for help. I'll see the same help message, I can say rate session. Which session do you want to rate? Intro to Lambda, let's say. What date was the session on? Last Monday. Where did the session take place? It took place in Ipswich. That's not a valid session location. So I've got validation in there. Okay, what I'm going to do is have a DynamoDB table that contains a list of places where I've delivered sessions in, say, the last 3 months. Okay, I'll use auto expiry on those events to purge them after a 3-month period, so they'll get deleted out. Okay, and I'll then be able to use a little web app to add new locations to that from whatever event I'm at, and that will be where my validation data lives. So my validation data will ultimately live external to my function. Okay, so I can modify it without having to push new code. Try a different location. I'll try London. Yep, rate the session 3. Submit this rating, yes. Thank you. So you've got exactly the same interface, but delivered via the Facebook channel. The only difference there is every time I interact, one of those webhooks is getting fired bidirectionally. And that's what's delivering the user experience from Lex into the Facebook chat session. Very, very simple to implement. Can integrate with Twilio for SMS. I could integrate with Slack and deliver exactly the same experience via the different channels. Or I could have different aliases for the same function, which deliver channel-specific functionality if I needed to do so. One example of a situation where I might use that is the fact that we have support for cards. So we can deliver graphical user elements into Facebook chat using a standard that Facebook have implemented, defined, that enables us to embed URLs and embed images in responses to messages as well. So we may have that functionality only in a test version of our bot that we're using on Facebook, pointed at one alias, and then we may have other functionality in a production version pointing at another alias for other channels. So you have flexibility to route, have the same bot serviced by a number of different versions concurrently, depending which channel the interaction's coming from. Okay, what else to show? I think that's pretty much everything I wanted to show, actually. Got about 8 minutes left. Does anybody have any questions here in the room? Does anybody have any questions on the stream that they want to ask? Yeah. In what sense?
So you say I want to book something with 2 of the bots.
So every initial interaction needs to resolve down to either no intent or one and only one intent. Okay, so the way that we are going to provide access to this for a customer is to connect a customer to a specific bot, either using a channel-based interface or using attributes in the API call that's made to the Lex API. Okay, and that will restrict the namespace of available intents to the intents that are defined within that bot. So I can't have the same namespace active and therefore have conflict between book a trip and my session rating bot. Okay, and I could have logic in my fulfillment functions that allowed a user to say, make a booking. Okay, and then respond back to them with, what would you like to book? Okay, so that's something that I can build in my dialogue hooks, essentially, if you've got that opportunity for customers to perform the same action on multiple different resources. I think is what you're driving at, yeah. Question here somewhere, I think. Do you have a question? There doesn't seem to be, the question is there a catch-all if you miss an intent? There is actually, and you can see it in my code here. So you see this intent with name is not supported. Well, that would be raised as an exception, but it would also, you could route that back out and speak it or render it back to the client. So you can catch undetected intents and basically say, I don't understand, or what do you mean? That's available as an option both in the console and available as an option in logic that you might build yourself in response to dialogue hooks as well.
Getting back to the earlier question, like you said, different matches one intent. Is there any way of seeing that if you have 2 intents that are quite similar, like this one was like 90% for machine learning and this one like 30%, so therefore if I did it, is there any way of seeing that? Because
you can log it, so you can't see if the model is conflicted. Okay, so that's not something that's available today. But you can of course log aborts. So you could build dialogue that allowed a customer to abort or drop the session midway through. Okay, and their session will time out automatically after a predefined period, which you can see you actually set within the console at the top level, so above the intents. So what I would suggest doing to detect that in your workflow is to use things like CloudWatch metrics and logging to determine to what extent customers are abandoning sessions midway through, and use that as a mechanism for resolving down and trying to identify issues of that type. So it's not a component of the service, but it's something that you could build by doing analytics around service usage.
Could you have an intent that this isn't like clear, so if you're in the middle of something,
Yeah.
clear it altogether?
Yeah, you could do that. Or you can offer the opportunity to cancel. Yeah, at the end. And typically that takes place at the end of the collection process. Yeah. Question over here.
Is understanding correct that the model your bot operates on is fairly static? That there is currently no way from Lambda to influence the slots who need to be filled dependent on prior data?
So the question is the model static, and is it the case that there's no way in Lambda to fill the slots depending on prior choices that the user might have made? And the answer to that is no, it's not. You can assign default values to slots as part of your application logic. Okay, so in my code here, I could...
Sorry.
Go ahead.
Now let's assume in your bot you want to use different scenarios. A specific slot makes only sense in a specific scenario.
Yeah.
So they should be excluded.
Yeah, so you'd write that in your validation logic. My answer still holds true. You would write that in your validation logic. So, I mean, let's take an example here. Say I am booking travel, and in my corporate travel policy, for certain destinations, it's mandatory that I book a hotel whenever I book a flight. Okay, but for other destinations, it's not mandatory that I do so. So I can book a flight independent of booking a hotel. I can create logic that represents that business rule inside my dialog handler. Okay, so I could say, for example, have an attribute which was, do you need to book a hotel? Okay, and then I could evaluate the contents of the destination slot, and if the destination slot matches a subset, I could assign a value to do you need to book a hotel to no, okay? But if that value is unassigned, then I could prompt the user for a hotel, for the details of a hotel. Do you follow? So you're having conditional logic in your backend, but that is statically defined. It's not something that is dynamically defined.
So let's say, sure, we do it a little bit from the back side. So when your validation logic is see that slots are not needed, you put them on default.
So the question there is, can you assign default values to slots? And the answer again is yes, you can do that, but it would be in your handling function. So to do these kinds of advanced or support these kinds of more advanced use cases, more advanced logic flows, you can't just do that with the simple front end to collect slot values. You're going to have a Lambda function which implements the kind of logic that you're talking about. But yes, you can assign default values to slots when you hit the Lambda function. Return them back to the client in the session attributes, and then the client will not attempt to revalidate and recollect those slots again. So yes, you can do that. Any other questions in the room? We've got 2 minutes left, so I'll take one more. Go ahead.
Regarding the utterances,
Yes?
how rich does the scope of the utterances have to be, and is there any documentation regarding how to limit or how...
Yep. So the question is, how rich do the sample utterances have to be, and what sort of documentation exists? I'm glad you prompted me on the docs, because I'm going to show that to close. But the sample utterances, the more you create, the better the bot will be at picking up the intent. Okay, so I've got quite a few here, because I identified in debug that I was picking phrases out of my head randomly for rating, and the intent was not being detected. So I built additional to help resolve the intent more accurately. But you might have noticed in the other demo bot that I showed you, the book trip interface, the very light, Okay, I would book a car, reserve a car, make a car reservation. So it's very light, okay? And if you've got intents that could potentially conflict, as I've got leave a rating and leave feedback, they're quite similar, then I probably want to have more example utterances to help me resolve down. Okay, so the last thing that I wanted to show is documentation for this service, which I think is something that's really important. Here you've got just a sample from the documentation, which is the response format. So if you want to write your own backend, these are the objects that you're going to be dealing with that are going to be passed to your Lambda function for interpretation and evaluation. This is probably the most important part of the Amazon Lex docs for developers that want to build rich validation experiences. So understand this schema, okay? And understand particularly things like fulfillment code hook and dialog code hook. So when you need to fulfill, your session will be tagged invocation source fulfillment code hook. It means all slots have been filled and you're ready to go, okay? If you pre that state, you'll be getting dialog code hook, which means not everything's here yet. You need logic to help gather more responses or validation logic to help make sure what you have is valid, okay? So it's a really important part of the docs, and I'd recommend if you're going to start working on this with anything sophisticated, take a look at that. Okay, we're out of time, I think, so thank you. Thanks for joining us on stream, and I'll see you next week. Bye-bye.